Hello everyone, welcome back to Algebra 2 class. Today we are going to discover some new properties of logarithm, and the title of this lesson is called Law of Logarithms. So if you do remember, when we talk about exponents, we actually have several properties of exponents, such as the first one, for example, when we multiply two powers together, we actually add exponents. So for this case, it's going to be n plus n. For example, 3 to the second power times 3 to the third power is going to be 3 to the fifth power. We add exponents. And when we divide powers with same basis, we subtract exponent. So for example, is 5 to the third power divided by 5. When we write no exponents of this, it's actually invisible 1. So it's actually 5 to the second power. And for the power of the power, we actually multiply exponents, and such as, for example, 2 to the third power times 2 times, not really times, 2 to the third power, then second power is going to be 2 sixth power. We multiply this, and you can even just, rewrite this as a definition. You will see this is exactly the reason it happens for this kind of property. So as we mentioned before, logarithm is actually strongly related to exponents, which means the property of exponents is going to be applying to logarithm, but in a different format. So today we are going to discover what these properties are and how do we use them to simplify expressions with logarithms. Okay, so before we release these answers, these properties for logarithm, let's just check some examples and to see how is that happening. So for example, log 2 to the 8th, and whenever we write down the log, we actually ask us this question: 2 to what power is 8? Remember, log is always looking for exponents. So 2 to what power is 8? 3. And log to 4. 2 to what power is 4? Which is 2. 2 to the second power is 4. Log to 32 is actually 2 to what power is 32? If you think this number is a little bit bigger, you can just keep trying, keep multiplying 2 to see what you can have the answer, which is actually 5. So I want you to pay a little bit close attention to the numbers we're dealing with here. As you can see, the power here, 8, 4. 8 times 4 is actually 32, right? And this number 3 plus 2 is actually 5. So it seems that log to 8 plus log to 4, well, equals to log to 8 times 4, which is log to 32. So we use a number as example telling us when we have the power multiplication together, the exponents, remember log is actually looking for exponents, so these two are actually adding. So same as this one, when we multiply the power, we add exponent. So we are going to generalize this formula for log. The first one, product property for log, is actually, remember, we're working on the same base, such as regular base b, and we're going to deal one of the power is, let's write down this, and if we're dealing with multiplication, we can actually break down is 2 part. Same as if I add 2 logs, I can multiply the power together. Okay, so this is the first logarithm's product property. When we multiply the powers, we can break down the sum of 2 logs. Okay, this one, log to 16, which is 2 to what power is 16, which is 4. 2 to what power is 8? 3. 2 to what power is 1? It's going to be 1. 2 to what power is 2 is 1, sorry. So I just want to, again, pay attention to the number relations here. I'm going to rewrite this. So it seems that log to 16 subtract. So 4 minus 3 is 1, minus log to 8 is actually equal to, remember this 2 actually we can consider 16 divided by 8. So it seems like 16 divided by 8 is actually equal to 1. So if you pay close attention, when we divide powers, we actually can subtract the logs. So the second one is actually coming from the quotient part. Again, I just give you these numbers just to give you an idea, you know, the connection between these two. But later we are going to do more practice to let you get familiar with this kind of properties, okay? So this one telling us if we divide by powers, then we can just subtract exponents, subtract logs. So when you divide powers, you are going to subtract exponents, which is subtract logs. For this one is, I want to give you a simple example here. For example, let's say log 2 8 square. We know log 2a square is actually log 2. 8 times 8 is going to be 64. And for this one, again, if you do not know this, you can just keep multiplying 2 and test it how many times you are going to get a 64. The answer is actually 6. But another way to rewrite this is I can put this 2 in front of this, becomes 2 times log 2 8. We multiply the 2 exponents together. Log 2 8 is 2 to a power is 8 is going to be 3, so it's 2 times 3. It's actually the same as this. So this one, the power property for the logarithm says if you are dealing with power of the power, I can move this little t to the front. I times this power. Okay, so these are the 3 properties here. The product property for the log, when we multiply powers, we add exponents. For the quotient, when we divide powers, we can subtract exponents, subtract the logs. And when we deal with a power, I can actually move this little exponent to the front to break down as multiplying these 2 exponents. Of course, you might have more questions regarding how do we actually use it. So in the following video, we are going to work on some problems and using this kind of property to be more familiar with how do we break down the logs and how do we, sometimes we combine, sometimes we divide, and then when do we use it, how do we use it. We are going to discover more facts in the following video. Okay, thank you so much for watching this video and see you soon everyone in the next video about this lesson.